In this video, we'll continue on with Chapter 7, moving on to movement disorders. The first one we'll discuss is Parkinson's disease. So Parkinson's disease is characterized by muscle tremors, rigidity, and slow movements. So these are the hallmark symptoms of Parkinson's disease. It typically starts with a unilateral tremor, so a tremor in one hand, and then it slowly progresses to a bilateral tremor where you have both hands are shaking. And then as it progresses, the muscles get rigid. It's not that the muscles can't move, but it's this difficulty in initiating physical and mental activities. So it starts with the muscle tremors, then the individuals get rigid. It's difficult for them to get up. They have slow movements. They have this characteristic stooped posture. They shuffle their feet when they're walking across the room. But again, it's difficulty initiating that physical and mental activity, these procedural memories. Another way of thinking about that is it's associated with an impairment in initiating spontaneous movement in the absence of some sort of stimuli to initiate it. Now, my father-in-law has Parkinson's, and one of the things that I've heard in the past is that a person with Parkinson's, they get up and they shuffle their feet this very characteristic way in order to get across the room. But if you put little stars on the floor and you say step on the stars, so there's something it's not self-initiating anymore, there's some sort of stimuli to guide the action, they can do so normally. My father-in-law has actually said that when they go down on their frequent little trips to Mexico, that sometimes what he'll do is he'll look at the tiles that are on the ground on the pavement, and he'll say, okay, step on every other tile. And if he does that, he has a much more normal gait. Now, why he doesn't do that all the time, I'm not sure. Parkinson's disease affects 1 to 2% of the people over the age of 65. And again, it has nothing to do with their muscles. It has to do with their brain, the basal ganglia, which is what we talked about in the previous video. Now, there are some associated symptoms. Now, these associated symptoms, these aren't the primary symptoms. Things like depression, memory, reasoning deficits, loss of olfaction, other cognitive deficits. And so these associated symptoms are often seen in people with Parkinson's disease. Now, you're going to do an assignment where you're going to answer some questions. And one of the things is, what are the symptoms of Parkinson's disease? So when we're talking about the symptoms, we're talking about this up here on the top of the slide, that it's characterized by these tremors, rigidity, slow movements. And again, it's this difficulty of associating movements because of damage to the basal ganglia. So what type of memory did we say again was dependent on the basal ganglia? Procedural memory. And so here's just a reminder of what the basal ganglia looks like. Here we have the thalamus, it's in the center, and then we have our globus pallidus. We have an internal and external portion. We have the putamen. The amygdala is out here, substantia nigra sitting here, projecting to the caudate putamen, and then the thalamus projects to the cerebral cortex. So showing you the substantia nigra projects to the putamen, projects to the globus pallidus, which projects to the thalamus. The thalamus projects to the cerebral cortex. And this is what I showed you in my diagram on the previous video. This is just a representation from your book. Now, if you look here, it's showing you what's inhibited or damaged. Here we have this loss of input from the substantia nigra, because remember, people with Parkinson's disease lose 60 to 70% of the cells in the substantia nigra that produce dopamine before they even have symptoms. So that's the cause of the Parkinson's disease symptoms, is that loss of dopamine producing cells. So the substantia nigra is now not stimulating that putamen anymore. So the putamen, caudate putamen, is not inhibiting the globus pallidus. So now you get this increased inhibition of the thalamus, and thus the thalamus is unable to initiate movement by stimulating the cerebral cortex. So again, the primary cause of Parkinson's disease is a gradual and progressive death of dopamine neurons in the substantia nigra. So again, on that assignment, when I ask you what's the cause of Parkinson's disease, this is the cause. We're going to talk about some other potential things that could cause the cell loss. But I want you to understand that the underlying cause is a loss of dopamine-producing neurons in the substantia nigra. Both the brain region and the neurotransmitter are important. So the substantia nigra, again, as I said before, projects to the caudate nucleus and the putamen. Ultimately, when you have this loss of dopamine neurons in the substantia nigra, and here's this diagram up here of the normal pathways, you end up with less stimulation of the motor cortex, as we saw in the previous slide, which results in a slower onset of movements. So you have this difficulty initiating these procedural memories or these self-initiated movements. So this is normal functioning. Substantia nigra projects to the caudate inhibits the globus pallidus, that then decreases this stimulation and allows the thalamus to initiate movement by exciting the motor cortex. So let's see how that differs. So now let's see what happens in Parkinson's disease. So what you're going to see is this projection decreasing or going away as a dotted line, and then you'll see, watch what happens here to the input from the caudate to the globus pallidus. If you no longer have a substantia nigra stimulating the caudate, what's going to happen to this inhibition? So watch this. It decreases significantly. So 60-80% of the cell loss in the substantia nigra, that leads to a decreased stimulation of the caudate and a decrease in the inhibition of the caudate putamen. Show you that one more time. So as this goes away, this inhibition decreases. Now, let's watch and see what happens when this inhibition decreases to the globus pallidus. So let's go back to normal. Here's normal functioning. So now let's take a look at when the substantia nigra normally stimulates the caudate. The caudate inhibits the globus pallidus, and so there's a decrease of inhibition from the globus pallidus to the thalamus. Now, if we take away this projection, this is decreased. Let's see what happens to this inhibition. So keep an eye on this inhibitory response. It increases. So the globus pallidus is now inhibiting the thalamus at a greater rate. The thalamus is less able to stimulate the motor cortex. So let's watch this one here just to see that. So here again is under normal conditions. And this is what happens in Parkinson's disease. We have a decrease of stimulation from the thalamus to the motor cortex, and thus an inability to initiate these self-initiating movements. Now, I know this might all seem complicated, but just keep in mind what you're trying to remember is that Parkinson's disease is the inability to initiate movements because of this loss of cells in the substantia nigra.